All right, let's go over the Chapter 7 Sample Test. Number 1. Okay, tossing a coin and a regular six-sided die. A coin could come out heads or tails, and a die can come out 1, 2, 3, 4, 5, 6. So there's 12 outcomes. Now A says list all the outcomes. Tossing a coin, it could be a heads with a die being 1, heads 2, heads 3, heads 4, heads 5, and heads 6. Or it could be a tail 1, tail 2, tail 3, tail 4, tail 5, tail 6. B. Draw a tree diagram. Well, the coin could come out heads or tails, and the die could come out 1, 2, 3, 4, 5, or 6, and or tail in 1, 2, 3, 4, 5, and 6. There's a tree diagram. C. What's the probability of getting A? And A was, let's write that down, A was head showing. And B was even number. So the probability of a head showing, is 1, 2, 3, 4, 5, 6 of the outcomes. These 6 out of the 12. C. D. What's the probability of A and B? So that's, and is one box, not 3. It's the only one that has both A and B. You might, every time you see and, you might say both A and B. So it has to have a head, has to be one of those, and it has to be even, which is just those 3 out of 12, which is 1/4. E. A or B. So in that case, it can be either A or B or both. It doesn't, it has, this has to be both. This says one or the other or both. And so heads, there's 6. Evens, there's 6, but we don't want to count those 3 twice, so we got 6 plus 3 more down here with the tails, so that's 9 out of 12, or 3/4. And then F, determine the odds of not getting A and B. Odds not A and B. Not meaning the complement to A and B. And odds are what you want over what you don't want. So, how many ways are there to get A and B? A and B, there's 3 of the 12. The complement would be the other 9. So there's 9 ways of getting not A and B out of what's left. If there's 9 ways to get, let's see, A and B is 3. So not getting A and B is 9. And the rest of them are 3. So the odds are 9 to 3. G. A given B. Probability of A given B, or A given B. That line means given. So that's the shorthand. So now we have to think B has happened. B, there's an even number. So we're in this 6 even numbers. B has happened to. So of the 6, how many are A? A was ahead. 1, 2, 3. So that's 1/2. And then H. Are A and B independent? So since we have the probability of A given B, we want to compare that to the probability. This says the probability of A, knowing B happened. The probability of A, we want to compare it to the probability of A. We want to compare apples to apples. What's the probability of A? And what's the probability of A if B has already happened? Well, the probability of A we did earlier, and that was 6 out of 12, or 1/2. So I would write these are equal, because this is 1/2, this is 1/2. They are equal, so A didn't depend on B. Knowing B happened didn't change the probability of A. Probability of A was 1/2, probability of A was 1/2, probability of A knowing B happened was 1/2. And so they didn't change, so independent. It didn't depend on B. Okay. All right, now, that was 1. There was a lot of parts to that. Of course, the test won't ask you all of those, but I'm just trying to get you to think about things here. I think I got room enough to do 2 here. 2. Determine the following probabilities and state whether your answer is theoretical, relative frequency, or experimental, or empirical, or subjective. Drawing a king on a single draw from a standard deck. There's 4 kings out of the 52 cards, and so that's the probability. It says determine the probability, so that's the probability of drawing a king. And did we do it by experimenting? No. We did it by every card's equal chance, and so we did the theoretical. B. The winter will be the snowiest in the last decade. How do they know that? I think that's somebody just throwing something out there. I think they've got maybe a gut feeling or something like that, so I think that would be subjective. And the winter will be the snowiest in the last decade? Probably a 10% chance. If it's subjective, we can make it up, because there's no other way to get the probability. So I'm going to make it up because it's subjective. And C. The big lottery window is below poverty level if 13% of the last had, okay, the next big lottery winner is below the poverty level if 13% of the last 100 big lottery windows had incomes above the poverty level. So what's the probability the next one would be? So if 13% of the last 100, so 13 out of the 100 were winners, were above the poverty level, then 87 out of the last 100 were in the poverty level, below the poverty level, and so that means The next winner being down there would be that, or 87% chance. Okay, let's go to 3. Simply Burgers. Its business is serving only burgers which have a special sauce, lettuce, and onion. They always have that. So don't get that confused. That's not a choice. They always have sauce, lettuce, and onion on it. Even if you don't like onion, they're on there. And so now they do allow customers to decide whether to add tomato, pickle, or cheese. And it always comes with 3 choices for side. Always have one of these 3. So you got to have one of the 3. So we're going to make a tree diagram. So there's no choices on the burger, sauce, lettuce, or onion. You're not choosing a burger. There's only the burger. That's all they have. So now the first choice might be to have, okay, so you can choose to add tomato. So you can have tomato or not tomato. Then you can choose to have pickle or not pickle. And then you can choose to have cheese, because it says and or. So you could have tomato and pickle, or tomato and not pickle, tomato only, which would be there. And what was the other one? Cheese. Cheese, not cheese. Cheese, not cheese. Cheese, not cheese. Cheese, not cheese. Now I'm going to be in trouble here, because now I have to have, and it says I'm going to have one of the 3 sides, so I have to choose fries or salad or apple pie, and I need to put those on each one of these. So I've gotten too small to do it, but I don't want to get out of your video, so I'll stop with that. So next, then we got to go to how many. Oh, make a tree diagram. So I got the tree diagram. I just made it too small here. B, that's A. B. How many possible burger meal combinations are there to choose from if you consider the choices of adding or not adding tomato, pickle, and cheese, and you get one of the sides? So 2 times 2 times 2 times 3. 2 times 2 times 2 times 3. We're going to have out here 8 times 3, 24 branches. And that's how many different burgers there are to choose from. If a random burger meal is selected, what is the probability that the meal has tomato or salad as part of the meal? Tomato, that's all of those branches. Half of them have tomato, so that's 12 that have tomato. Or salad. Salad will be 1/3 of them, but we've counted some up here, so we only want to count the salad ones down here that don't have tomato. And so there's only, so that we don't count the overlap, salad's the middle one. There's one there, one there, one there, and one there. So there's 4 more down here. There's 8 meals with salads, but only 4 additional that don't have the tomato. So plus 4 more. So what's the probability? So that's out of all of them. So, and it's or, so we're adding. So 12 plus 4, 16 out of 24. And if you reduced it, 8 goes into those 2/3. 2/3 of the meals will have either a tomato on it and or a salad with it. And number 4 is in the same group. 4. Oops, circle the whole number there. 4. What is the probability that at least one condiment on the burger, that there is at least one condiment and the burger and there isn't a salad? At least one condiment, which would be 1 minus no condiments. Where's the one that has no condiments? Well, that would be those 3. 3 would have no condiments out of the 24. So at least one condiment. So there's 24 minus the 3. 24 out of it minus 3 out of the 24. So there's 19 that have at least one condiment. And there isn't a salad. So of the 19, which is all of those, and there isn't a salad, so we got to throw out 1/3 of what, let's see, 24, this would be 21, excuse me. There's 24 minus the 3 is 21 of them. 3, 6, 9, 12, 15, 18, 21, but only 2 of those don't have a salad, so it's really 2, 4, 6, 8, 10, 12, 14 don't have a salad and have at least one condiment. That's everything except that bottom branch. So out of 24, there's the probability of that. That's a tricky one. If I put that on the test, that might be a bonus. Okay, I'm going to go to 5 on the next video.